My name is Jeremy Edberg, and today I'm going to talk to you about deploying for Lambda. So, what is this fuss about serverless computing? Serverless computing is all about speeding up development by allowing rapid iteration and removing management overhead, particularly server management overhead. It's the smallest unit of compute, so it makes it super scalable, easy to iterate, and it's really friendly for polygut, and it's really easy to collaborate and deliver. So what is serverless anyway? Serverless does not mean that there are no servers. There are still servers, it's just that you don't manage them. It also means that you don't get to access them anymore, for better or for worse. There's a whole lot of choices in serverless architectures. There's a hodgepodge of third-party services. There's Amazon's ecosystem. You can mix and match all of those choices together and work between them, or you can just focus on Amazon's ecosystem, which is what I'm going to be talking about today. The important part here is that there are no servers that you're managing, regardless of whose they are. So specifically, I wanted to talk today about Lambda. So how does Lambda work? It starts by writing your code. So you can use Node.js or Python right now, or Java or any JVM-based language like Scala or Scala, depending on who you talk to. You get access to /temp, so you can store stuff locally temporarily. The AWS SDK is built right in, so you can access things like turning instances on and off, or listing them, or S3, or what have you. And you can upload any library you want to. Once you've authored your code, you need to deploy your code. They provide you with a terrible UI to do so. You can use that, or you can try to upload it directly to S3 or Lambda yourself. All of these, of course, are very difficult and error-prone. Once you've done that, you have to store your data somewhere. There's no local instance access other than /temp, and that only lasts a few seconds while your process runs. So you're going to have to figure out storage for yourself. Luckily, Amazon provides a lot of options for you, like Dynamo and S3. So once you've done that, what does the deployment process actually look like? First, you write your function, then you create your IAM role, you add your permissions, you have to zip up everything with their dependencies, you have to run your tests, you have to add an event source, and then you have to view the output. This is all very complicated and requires lots of steps. Again, you can try to do that with the console. This is what it looks like. It's not very intuitive and not very easy to use. Or you can use the open source project that my company's created called Kappa. And what Kappa does is it takes care of all of that stuff on the left for you. So it does all of that for you at once. And I'm going to demonstrate it for you right now. So I created a word generator. What this does is it generates English-looking words using an n-gram database from Google. You can specify prefix, suffix, etc. Here's some of the files look like. So the first one I want to show you is kappa.yaml. This is the configuration file for Kappa. At the top there you see the name, which will be used later for service discovery. Then we define the environments. So that profile there is your AWS command line profile, which is just a config file on your local box that has your private key and your access key. The region specifies which region you want to run Lambda in. There's only a few that you can, and you can only do one at a time. And then the rest are policy definitions, shorthand policy definitions. Then the next section is about Lambda itself. So it has a description. Handler is basically which function inside which source file should receive the initial incoming data. So when you call a Lambda function, you call it with JSON, and it needs to know where to send that. The runtime specifies the language that you want to use. Memory size is how much memory to allocate to this Lambda. All of Lambda's pricing and sizing is based around memory, so you specify the memory and they give you a specific amount of CPU and network based on that. And then you specify the timeout in seconds. What's the longest amount of time that this process can run for? This is the WordGen file itself. This is just the handler portion. There's a bunch of other code which I'll link to at the end. But this is the handler, and so you can see here the event is basically what's being passed, the event and the context. This is what Lambda passes into you. So you can see here how we're using event. We don't actually use context for this. And then this is our testing JSON file. So it just has two options, the words and the prefix that I want to use, which you saw were used in the handler. And then this is that ngrams database. So this is actually just a SQLite file that specifies all of the ngrams. So you can see I just threw that right there in the source directory. So when we zip all this up at the end, it's all going to get zipped up together. So let's take a look at what that deployment actually looks like. Basically, after I put all my files there, I just say kappa deploy. By default, it'll use the dev environment. So you can see here that it's pausing to create the function. What it's doing there is zipping everything up and putting it all into one big zip file. So it takes a little while because of that ngram database. And now we're going to invoke the tests using kappa. So kappa will now call the function with that test JSON file that I showed you earlier. And you can see here the debugging output. You can see that it took 2.1 seconds. It used 33 megabytes of RAM. And I like that third word that it generated, opsender. That's a cool word. So that's basically how the deployment works. So now let's make a quick change to our test. And instead of having it generate 10 words, we're going to have it generate 20 words for us. So we're going to save that out, and we are going to invoke our test again. And so it's once again calling out to Lambda with that JSON file. And oops, something bad happened. You can see here the error response. It timed out after 3 seconds because we have specified the max of 3 seconds. Luckily, this is really easy for us to fix. We're just going to edit our kappa YAML, jump to the bottom there at timeout, increase it by an order of magnitude to make sure that we have enough time to run the functions and generate the words we want to generate. We're going to redeploy that. And then we're going to run our test again and make sure that what we did actually worked. So it takes a little bit longer this time because we're generating more words. And so let's look at what happened. You can see here that as it was deploying, everything was unchanged, everything already existed, so it didn't have to do anything except update the configuration for the Lambda file. That's the only thing it had to do. Then you can see here it took 4.2 seconds to run. So it was a good thing that we changed our timeout to 30. It allowed us enough time to actually run the function. And here I love the second word, obsessity. It could mean lots of things, but the whole purpose of this word generator was so that I could create company names and product names without having to think about it as much. So actually, I used that word generator to come up with the name of the product my company makes called Yobot. And I wanted to tell you a little bit more about the architecture of our product. So our product is a chat bot that lets you query your Amazon infrastructure via SQL or natural language. So this is the perfect architecture for Lambda because it's event-based. Every time someone makes a query, it generates an event. So this is perfect for Lambda. The way it works is the user types a word. We send that to our container, our ECS container, which is just running a little tiny piece of code that marshals the data from Slack to Lambda because there's no way to get it there directly. It sends the data out to Lambda, which sends it to router.py, which I'll show you in a moment. And what that does is it'll call out other Lambda functions. That Lambda function may or may not use a Dynamo database data store, for example. And then once it gets its data back, it sends that back to the router. The router then takes that, sends the response to SNS, so the queuing service, and it also sends a copy to Kinesis so we can store and log everything that we've done, and we can see things moving through our system. SNS then sends that back to that container that essentially just marshals the data back to Slack. So that is the basic architecture of our product. So yes, we technically have a server in ECS, but in reality, all it's doing is marshaling data, and hopefully Slack will eliminate the need for us to do that soon. So this is router.py, and up there's some functionality and a surprising amount of comments for a startup. But basically, the important part here is we have a list of functions, other Lambda functions that we can call. And so we go through that list to determine which one based on the data that came in, and then we call that function. And you can see here on the right is the call Lambda function code. So this is the code that basically calls one Lambda from another. And what's really important to notice here is that nowhere do we have to go and do any service discovery. All we have to do is provide the function name. So if you're using Kappa, then you have already specified that name at the top of the Kappa YAML file. So you can just use that name here. And so what's really nice about this is that it solves the service discovery problem because you don't have to worry about it. Lambda takes care of that for you. So here's an example of somebody trying to type in something that our bot does not understand. So I've gone ahead and I edited the code. You can see there the code. I'm adding a match for that phrase. I'm going to deploy it. You'll notice this looks very similar to the deployment we did before. The only thing changing this time is the zip file because the function changed. So it's made a new zip file. And I've deployed it to dev, and so I can type it again, and now you can see that I support that phrase. So that was the entirety of adding a feature to my product. So now that I've tested it in dev, everything looks good. So I'm going to do a git status. We use git flow at our company, the git flow method, you could say. So I'm going to commit it, and then I'm going to push it up. And I can never remember the code for, or the correct command for pushing. So I always just say git push, and git just tells me what it is. So all I have to do now is push it up to GitHub. GitHub gives me that handy compare and pull request button. So I can just hit that, create the pull request. Since I'm an extreme programmer, I don't bother to have any code reviews, so I merge the pull request. And that's it. Now I just deploy it to prod. So you can see that we've taken a shortcut here. We have a script called deploy, which I'll show you in 1 second. So again, in prod, same thing. We've updated the function there. And that's it. So the nice thing about this is that I went from the conception of this feature to prod in 5 minutes when I was doing this for real. And half of that 5 minutes was taking these recordings. So I was able to basically deploy a brand new feature, think of it, and deploy it within just a couple of minutes. I didn't have to worry about any sort of OPSI type stuff, except for Kappa deploy, but I'll get to that in a little bit. So this is what that deploy script does. Basically, all it does is make it so that we don't have to remember the command line options for Kappa. So it just defaults to dev. Otherwise, if you say prod, it types prod. It's super simple. This is the Kappa YAML file for that function. And what's important to note here is that there's 2 environments defined, a dev and a prod. Each one is using a different profile, AWS profile, on my local box with different sets of keys that go to different accounts. So this makes dev and prod really easy to do. And here's what the code. Here's a snippet of the code base structure for our Lambda files. So you'll see that we have a bunch of Lambdas here: action database account, action cost, action feedback. They're all in a Lambda directory, and each one has its own kappa.yaml file. So each one has its own config that defines its handler and its timeouts, and so we can have different memory and timeouts for each action depending on how much they need. There's these JSON files which provide configuration information, which I didn't really get into, but essentially it's to let you there's a way to grab these configurations during the running of your Python. This is the requirements.txt file. So anyone who's familiar with Python and pip knows about requirements.txt. This basically specifies all of the dependencies that your function needs. And one of the things that Kappa is doing is looking at these dependencies. You still have to install the dependencies separately. Kappa does not take care of that. So you still have to run your pip install anytime you've changed a dependency. And I'll get into that in a minute. And you can see here some of the artifacts that Kappa has left behind. These are the zip files that are actually being uploaded to Lambda. So the nice thing about Lambda is that it basically lets you manage your code and your infrastructure in the same place, as long as you're using something like Kappa or any other of there's a couple other deployment systems out there for Lambda. And the nice thing about Lambda is it lets you follow the very standard practice of microservices deployment. So each Lambda function can be built, tested, and released independently, which is nice because if you have small teams of developers, each one can be independently working on different functions, or different developers can work on different functions. So a couple of tips and tricks that we've learned so far. Make sure you set up alarms on all those Lambda CloudWatch metrics. We've been burned by that a couple of times. You can avoid throttling, so when you communicate from one service to the next, there's going to be some throttling, but if you go through SNS, it helps avoid that, because SNS has a much higher limit of data that you can push to it. And beware of infinite loops, functions calling each other. So when you're operating with such small functions, it's really easy for one person to just call another one, not realizing that they're being called back. This has happened to us already a couple of times. It's a really easy mistake to make. So the best way to avoid it is to pass your call stack when you call one Lambda from another, and then as one of the pieces of data that you send. And that way you can check to see if you are in the call stack and make the appropriate choice as to whether you're going to call that an error or not. Building a nano service is much like building a microservices. You could start with your monolith, you break it down into microservices, and then you basically keep breaking it down until there's only one or two functions in each Lambda chunk. Because that's about what's going to be able to run under Lambda's constraints. The maximum is 5 minutes. Now, 5 minutes is actually a really long time, but that's when you're going to start getting into the higher billing. So you really want to try to keep it down into just a couple of seconds if you can for running each Lambda function. The nice thing about Lambda is a good architecture is going to be forced upon you. Your front end is, if you want to be truly serverless, your front end has to be hosted somewhere and be basically JavaScript. Your back end has to be one of these other languages. But SOA and proper APIs are necessary because that's the only way your functions are going to be able to talk to each other. So some of the difficulties that we initially ran into with Lambda that we solved with Kappa are this zipping up the dependencies, setting all of the roles and the permissions, figuring out dev versus prod. By having these two environments in the Kappa YAML, it makes it really easy to deploy to one or the other. And aliases, naming functions. By being able to specify them in the Kappa YAML, we avoid a lot of problems that way. And we don't have to worry about service discovery. Some of the problems that we still have with this, though, are efficient dependency usage. So one problem is a lot of our functions require Boto, for example. So Boto has to be included in every zip file. There's no easy way around this. We could theoretically deploy a Lambda function that's just Boto, but that actually makes things more complicated. So this is a problem that we haven't really solved yet. Local dev environments. It's really hard to test this stuff locally. For the most part, you have to upload your function to Lambda to test it because it operates differently. Some things you can test. So we do have like nose tests that we can run locally on some of the functionality of each function, but then an integration test really has to be uploaded. Making sure we all have the same dependencies. So when someone changes requirements.txt, everybody who's deploying that function in the future needs to make sure that they run pip to get those latest upgrades. So we've definitely run into problems where I will be working on a function, or someone else will be, they'll change the requirements, I won't realize that they've done that, I don't run pip every time I deploy because that would take too long. And so we end up pushing it out with the wrong dependencies, and then all of a sudden everything breaks. And another problem we're having is that sometimes some people will be working on the same function, and so they'll be deploying over each other in dev because they're testing their own changes. So you'll deploy, you'll test, it'll work, you'll go get your coffee, you'll come back, and all of a sudden it's not working anymore. So our next step is to automate further our deployment pipeline, and we're almost to this point, but not quite yet. So basically the developer will make their code, they'll check it into Git, and we'll have the dev branch automatically deploy to dev and the master to prod. So if you really want to test, what you'll have to do is set up your own Lambda infrastructure to do your own testing so you're not clobbering everyone else. And then when you want to do your integration tests with everybody, you do a pull request against dev, get it approved, and then as soon as it's merged, it will send a webhook to a Lambda function. And that Lambda function will actually do a git pull, and it'll do a pip to get all the requirements, and then it will zip everything up and deploy that out to Lambda. Once it's deployed to Lambda, the tests will be run, the data will come back to our integration Lambda function, and then that will store an entry in a DynamoDB database that says this is the deployment happened at this time by this user with this output. And then they'll also send a message to SQS, which will go back to the user to say, here's the results of your deployment. So the nice thing is that will eliminate at least two of the problems that we have, making sure we all have the same dependencies and no one, when someone else is clobbering you, we still won't have solved the efficient dependency usage or the local dev. And testing is really just a difficult problem in general. You can't test the network, for example. If you write your application well, hopefully you've done good programming, defensive programming practices, where you can protect yourself from most of the network failures. But you can do some local testing, but you can't really mess with the lambdas itself. You can also send your JSON to the function and compare the results, but again, testing in general with Lambda is just pretty difficult right now because there just isn't a lot of infrastructure. So if you have any questions about what I just talked about, that's all the ways that you can get to me. Or you can just click there on that questions link, and that'll take you to a Reddit that Reddit where I've submitted this talk so that you can ask questions, and I'll be following that and answering it. Or you can check out the WordGen code on GitHub, or you can sign up for the beta of my my product. So thank you very much. You're still here? You should click on one of these links. It'll be much more interesting than listening to silence.